Okay, in this presentation I want to speak about analyzing developer workflow. And in passing, I also want to connect this area in software engineering to mining software repository. There is a paper that goes with this presentation today. The paper is written by me and colleagues at Facebook recently. We also presented this as ICPC 2020, International Conference on Program Comprehension. And I also had a keynote at the same conference where I covered this and two other topics. All right, so we are going to analyze developer workflow. A little bit more explanatory version of developer workflow would be understanding what software engineers are working on. And more specifically, I'm focusing on what I call the work item prediction challenge. So it's basically trying to predict the kind of work item a person is working on at a given point in time. So let me present two scenarios where we want to predict work items, and these are my two cats, Ada and Kathy. Obviously this is their work item at this point. So the first scenario is the what I call incident response scenario. So there's some sort of incident in your development team. Let's say there's some alert coming in through some monitoring system. The alert kind of highlights some suboptimal performance. So this is the incident you're dealing with. Now the question is, what sort of steps should an engineer follow in responding to the alert? So this would be interesting to know, right? Suppose you are new in the team, you are on call, you're facing this alert for the first time, and you have to figure out what steps to follow to respond to the alert. So it would be nice if the kind of steps that engineers have previously taken for such an alert, if those steps were recorded and you could just rely on them. So this is what we also sometimes call automatic documentation, right? So we need to somehow record steps as engineers, maybe experienced engineers, deal with these alerts, and so that subsequently possibly less experienced engineers can benefit from it. So the challenge here is, if you want to record those steps, we have to know when someone is working on a response as opposed to doing something else. The fundamental assumption is here that engineers are possibly working at multiple things at once, maybe at two alerts, right? Maybe at two completely unrelated alerts. Or maybe I'm working on the alert, but while I'm waiting for some whatever database query to complete, I might be doing something else, right? So the challenge is here to know when someone is responding. So the challenge is thus to predict, to understand when the alert is the work item on the timeline of the engineer's work. Okay, so here's the second scenario. Call it the aggregate performance scenario. So this time, let's say it's not about alerts as work items, it's rather about diffs. I mean, diff is the Facebook term for system changes. Shippable commits in a sense. And I guess it's a common question to ask. I mean, this also goes by the term key performance indicator in management. We might want to know how much time do people spend on a diff, right? So we might want to kind of monitor such indicators, such as time spent on diff, over time, to see whether maybe there is some changes in performance, right? So maybe it really pays off that engineers have the latest laptop. Maybe they have a different aggregated average time spent on diff compared to engineers who are still on the previous model. So I mean, any sort of scenario like this, right, where we need these aggregated numbers, key performance indicators. Now, for this aggregation to happen, we also need to record all the activities on the diff, right? And very similar to the scenario we discussed before, the challenge here is to know when someone is actually working on a diff. Because, the person might be doing all kinds of things. For example, the person might be working on 2 different diffs. Or the person might just prepare some upcoming work, perhaps looking at a task or a bug report, and this is not really related to the diffs that are also nearby on the timeline. So very similar to the previous scenario, the challenge is on the timeline precisely for any given developer's timeline, any given action, is this action counting towards a certain work item or some other work item? Okay. So the challenge is there because timelines look like this, and we have what we call dark matter on the timeline. So dark matter in the sense that there might be some events here for which we really have a hard time trivially associating them with a work item. So let's say this is about diffs as work items. So when we have something like, I publish a diff for review, right? On here I publish another diff. This is not dark matter, this is white matter. When I publish a diff, obviously it's pretty clear that at that point in time, this is about a particular diff, right? Now, for example, down here, if I reviewed some diff, again, it's totally clear what I'm working on. Now here, if I commit a version locally, maybe just an intermediate version before I actually expose the change for review or for shipping, this is sort of already gray matter because, this commit, it's not immediately at that point in time tagged with any sort of diff. This commit might have some follow-up history of folding or splitting the change, so it might even end up in multiple diffs. So, but it's gray, it's not dark yet, because, by some sort of backward analysis, some chasing, I can probably, after the fact, associate a work item, a diff, with this commit. However, it becomes fundamentally more tricky when you look at those sorts of events here. So I'm running some database query interactively, or I'm reading internal or external documentation. This is what I call dark matter. These are events for which it's not obvious what work item they relate to. And this is the problem. I mean, we have those timelines, and people work on different diffs, and they do all kinds of things for which it is not so clear of what it relates to. And because of that, all these scenarios that I mentioned before are challenging. All right, so what we expect from any sort of solution here is that it kind of associates probabilities with all these nodes and with the underlying work items. So for example, here what you see is somehow by some analysis we figure out that there is a 0.8 probability that this database query actually has to do with this diff here, right? And or for example, this here, the consulting the documentation here associates with different probabilities with those 3 different diffs here. It's a probabilistic model that we expect, because maybe we cannot be sure how whatever heuristic or machine learning we throw at this, there might be some intrinsic probability that that we need here, in a sense that this documentation might actually relate to multiple diffs even, right? Which is what we have here, different probabilities in how it relates to the different diffs. Yes, and here we see for this gray action, the commit, we by backward chasing or whatever heuristic, we unambiguously associated with one specific diff rather than those other diffs here. All right, this is what we want, right? With work item prediction. And just to summarize this issue of dark matter, why do we have dark matter? Well, I mean, because the way we work with tools, the tools don't necessarily track the work items consistently, right? If I, for example, query the database, I mean, there is no tracking going on really as to what, let's say, diff or alert I'm working on. Maybe it could be better, but certainly today often we have a situation that tools aren't fully integrated, and so this tracking might not be that straightforward. Also, the logging we have, of course we analyze all kinds of logs here for work item prediction. The logging is not designed with workflow analyzers in mind. It was usually designed with kind of monitoring performance of the tools or adoption, like do people pick up certain features. It was not designed to support generously workflow analysis. And then to some extent we also have to accept that developer workflow is somewhat unstructured, right? I mean, developers, they might they pick their own processes. I mean, overall maybe the process is pretty clear, but in how they use all these different tools, that workflow is pretty unstructured. And more importantly, perhaps, that workflow also involves what we call context switching. So people might start with one task, with one diff, and then they get stuck or whatever, then they switch intermediately to some other task or diff, and then later they come back. And so there's lots of context switching. I mean, there's good reason why we have to context switch, because maybe we are waiting for feedback from reviewers or some other reason why we cannot or do not want to continue. All right, so these are all reasons that we have dark matter, that we have to disambiguate what's going on in the timeline. Okay. And here just an illustration of context switching. What we see here is basically just a timeline of one developer. I think this is maybe 2 or 3 days. And in the y-axis, what we see is a different, let's say, active diffs. So for example, here, this is where a diff starts, and you see it's still going on. Or here we see that together a bunch of diffs are reverted, but overall you see that there are many diffs active at the same time. So, which means, the developer is really busy with several diffs. They might be more or less related. Obviously here they are strongly related, we can assume, if they are reverted together. But overall, many of these diffs are possibly not very much related. But they are open, over the same period of time, at least for some part. And so obviously this means that for any sort of action that happens here or here, we need to figure out what diff is relevant for this action. I mean, there again, as I was showing with these dark gray and white actions, some of the actions are kind of what we call high confidence events. So they obviously relate to a specific diff, but other actions don't. And we cannot just go, because of this context switching and because of how these things are open in parallel, we cannot just go by time proximity, right? Just because I'm close to some high confidence event doesn't really imply that this particular action must also be counted towards some specific diff, right? So this is the challenge that we're dealing with here. So just as intermezzo, why am I discussing developer workflow analysis in the context of mining software repositories? I think it's pretty obvious. I mean, obviously, when we, for example, do predict diffs in terms of who's working on what diff, right? It feels like MSR because we need to analyze the repository, we need to analyze the system changes. However, it goes way beyond that, and that we need to look at all kind of logging because we want to understand each and every action of the developer and interpret it probabilistically towards specific work items. So in terms of how we use logging here, it's more general than the stereotypical MSR scenario. And then likewise, MSR is typically aimed at generalizable insights such as correlations or distributions, any sort of effects. And yes, we could also do this here, and it's pretty much immediately possible once we have a solution to work item prediction. For example, we could kind of quantify how much context switching is typical, like within an hour. So how many work items do I switch between back and forth? That would be something more MSR-ish. Or like, what is the typical confidence in assigning a specific time window, let's say 1 minute or whatever, unambiguously to a work item, right? That would be another way of looking at context switching, or also at the our ability to associate time windows with work items. Yes, these would be general insights, which we could immediately get once we have this overall work item prediction, but we are more interested in continuous prediction here, so that we can look at this particular developer and this particular alert and say, yes, for this alert, these are the actions, these are the time windows that we're dealing with it. So it's more point-wise, whereas MSR is often more aggregated kind of approach. Okay, let's talk a little bit more about work item prediction then. So I also want to characterize a little bit the tooling situation that I'm assuming here. And again, this is inspired by the situation we have or had at Facebook when I was there. So you really have a situation that developers work with possibly thousands of tools, certainly hundreds. If you want to draw a line somewhere in terms of importance of the tools. And so tools are added and removed and obsolete and change on a daily basis, right? All kinds of features, the functionality of tools changes all the time. The way how we interact with the tools through CLI or IDE or web-based changes all the time. And the integration between the tools also changes all the time, right? The locking, how we touch locking to the tools, again, changes over time. I mean, not just the schema changes, even when we still use the same schema, maybe the volume of data that's locked or the semantics of what's locked changes. So this is really a very tricky situation, which means it's really hard to just go and reverse engineer what locking is going on, or maybe re-engineer a little bit the tools so that better locking is going on. This is just a lost cause, right? We sort of have to essentially deal with the kind of locking that we find, and we also need to have an adaptive solution so that if locking changes, we don't have to invest a lot. This means we somehow really need to put ML to work here and sophisticated heuristics. All right, so at Facebook we built a system for diff prediction. It largely works like this. So of course we had to look at the locking available and use a good amount of locking anyways, but as I said, only fewer parts of the locking foundation are sort of hardwired into the system. And then in this system for diff prediction, we make the fundamental assumption that we look at time windows of a certain size for which we want to make predictions. So for pragmatic reasons, we kind of pick 10 minutes. So basically for each 10-minute window on the active timeline of a developer, we want to be able to kind of rank all the work items that an engineer has been working on. So for this ranking of work items to work, we need to have some baseline understanding of what work items a developer or an engineer could possibly be working on. So we call this candidate work items. So let's say if I have been definitely working on a number of diffs yesterday and maybe last week and maybe next week, if I can somehow aggregate such a set of diffs that I have definitely been working on and will be working on definitely, then for today I can assume that those are the candidates. I mean, not all of them, I would have worked on them. Well, if they already shipped the diffs, probably I'm not going to work on them anymore. And if I only start working on a diff tomorrow, well, I will probably not have worked on it today. But yeah, so you can do some sort of aggregation like this, okay? And then we have to go and basically rank those candidate work items for the given time window, right? So again, there's like the idea that some of the actions from the logs, they are conclusive. They are indicating that the engineer is definitely working on a particular work item, but many of the actions are not conclusive, and this is where the probabilistic ranking is really needed. All right, so let me show a few more details here, and I do this by means of sketching the data model that we use in such a system. So it starts basically with a table like this. So this is a big data table where we, for each employee, we gather all the windows in time where the employee was active. So this is basically kind of figuring out the timeline of the developers. So we don't care about, at night when the person sleeps. We don't care about the lunch break. So these are only the windows where the person is actually active in terms of using development tools. And then, we need to somehow aggregate the candidate diffs, or more generally the candidate work items. And as I said, we do this by looking around the specific time window or the specific day. So this is all here indexed by day. So this is the day. We look around that day a bit earlier and a bit later. I mean, maybe not too much later, because then the prediction has to wait too much to be useful for the given day. Yes, and then we just gather all these work items that a person could possibly have worked on. Okay, so this is how we actually expect to maintain or present the predictions. So we're going to have a final table, diff predictions here, where for each employee and time window and diff number, candidate diff number, we have a probabilistic prediction, and we also keep track of all the different heuristics in how they contribute to this probabilistic prediction. And the individual heuristics here / ML models are basically maintained in an extra table, so where we have a label 1 or 0 or something else to express whether heuristic basically assigns this diff number to this time window or not. All right, and so we do this for every day. Now, one of the heuristics is the Diff Analyzer heuristic. It's basically concerned with the normal workflow around creating diffs, version control, reviewing diffs, and maybe accepting and shipping or landing diffs, right? So we basically have a table like this, again, about the time window, and this time we have maybe the actor on the diff, and we have the owner of the diff. So we have a bit more detail here already to version control. So we have the actual diff and the version thereof. So it's basically a more tailored log here dealing with the workflow around diffs themselves in terms of high confidence actions. Now, another heuristic is called Diff Comparison. So this is about comparing diffs, strictly speaking, with changes that are going on a developer machine. So I'm kind of I'm changing files on my machine, and the question is, what diff will this eventually be, right? So okay, so there's different ways of doing this. So for example, we can go just by the file name extensions, or by the words in the file names, or we can look at the symbols used or defined in the files that are touched. So the idea is to somehow abstract from specifics of the file that I'm working with, and so that we can then use some sort of similarity analysis between what's going on your machine with the ultimate diffs that we try to associate this with. So this kind of similarity analysis is a very powerful tool to relate changes that are going on your machine with the eventual diffs. Okay, that's sort of also very MSR-ish. Now, another heuristic that I want to point out has to do with tool usage. So the idea is, since we have hundreds, if not thousands of tools, and let's say they're all web-based, or let's limit ourselves here to web-based tools, certainly, is there some way to, without understanding all these different tools, is there some way to associate a tool usage with specific work items? So let's look at an example. Let's assume that we have some sort of tool here, tool 42, and within the URL we also have some more parameters. It says talks T4711. So what we might see is that, even though we don't understand this tool here in particular, we might see that this tool used is in time proximity with some other tool which we understand very well. Let's say a tool that's about version control, a tool that's about code review, and those other tools that we understand, they would give us high confidence in what work item or diff we are dealing with. And so what we can hope for is that we can somehow learn the correlation between these work items and those other let's say keys that we have here, right? So, and then if later on this, let's say key 4711 or T4711, if it shows up on the timeline again, then we may take this as an indication that we are working on a work item that was previously correlated with that ID, right? So that's roughly the idea here, to build some sort of word index that learns from the reoccurrence of words, so that even if a word appears on the timeline without proximity to the work item ID, we can still conclude that we are working on the relevant work item anyways. All right, there are some details here, but let me skip them. The idea is that we basically build a work index, and that we build some feature vector that sort of quantifies in a way how much indicators there are that in the given time window we have words that in one way or another are indicative of a specific work item or diff number here. And not going to go into detail here what all these features mean, but again, they somehow quantify the correlation between the work item ID and other words, okay? And then we can build an ML model from this, and we can look at feature importance, and so by this we can then infer more probabilities for more time windows just on the grounds of URLs of tool usage. All right, here's just some indicators of related work, and this also gets us a little bit into mining software repository work, and so it happens also into process mining, because generally developer workflow analysis is strongly related to process mining. Like the first paper here, indeed, I mean, this is clear about mining software repositories. So this paper, for example, just tries to understand what is the process, what is the workflow used by developers when using software repositories through version control, etc. Right? So this is obviously very close to what we are doing here, except that we are looking at tool usage much more broadly. Or here's also an interesting piece of work. It's about understanding workflow in terms of how to use IDEs, right? Are there certain workflows how people, let's say, click through IDEs in order to get certain kinds of work done, right? It's also related here, but again, we don't assume the perfectly integrated, isolated situation of an IDE. We assume that we have lots of tools that are weakly integrated, and you definitely want to understand things that are going on outside the IDE. Right, and then there's some more work on IDEs down there, and here's even more related work. So this is a little bit more about, if you like, business process modeling, right? So, I mean, in a way, in process mining, you have a problem that's very similar to the work item prediction challenge, insofar that sometimes when you work with processes, let's say in a business context, you also don't have perfect case IDs. So you also cannot easily say this particular event, an event log, does it belong to this or that workflow instance? And there are some ideas how to address this in a process mining context. We'll not get into this too much. That might be a good point to wrap up here. So with this sort of project, we learned a bunch of things. So for example, we understood that much of the initial investment goes into some sort of event log integration. So while we do not want to deeply understand structurally and semantically all the different logs that we might consume, we nevertheless have to integrate some amount of log files anyways, and even before starting to semantically understand them, nevertheless there's some data integration effort needed to align, for example, how these logs deal with time and identities of work items, etc. So there's a lot of data engineering work usually implied. Now, when you build a system like this system for Diff Prediction here, it's quite a complex system from a data engineering point of view, because you have really dozens, if not hundreds, of pipelines that feed into this prediction system because of how are all the different logs analyzed, how do we extract features, and how we compute candidate items and things like that. So you get a rather complicated directed acyclic graph of pipelines that actually constitute a prediction system, and that's not completely trivial to manage. Challenge with this sort of system is the human-based validation. So ideally, you would just go with very straightforward supervised machine learning, where humans would just kind of give you good baseline data in terms of, yes, I've worked on this work item in this time window. No, I have not worked on it. It's really hard to get by because, especially in an industrial context. And it's hard to get by also after the fact. I mean, I cannot easily look at, lots of data and just make the decision. I mean, if I need lots of labeled data, this doesn't scale. And it certainly doesn't scale to ask the engineers to waste their time on labeling the data. So you have to sort of go with weak supervision here. And like related to this aspect, this sort of system also needs to perform heavy internal validation. So as you cannot completely rely on, supervision, you also need to apply all kinds of tricks to internally validate whether the data makes sense, right? So for example, if I use clustering in an unsupervised way, then I should check that the clusters that I'm getting, that they meet certain internal validation constraints, so that I can hope that the cluster that I'm getting actually seems to capture some intrinsic semantics here, right? So lots of the things you have to do in such a system is about similarity measures. We have learned lots of things about this. So just to kind of express it in very simple terms, remember I was talking about these dark matter events regarding database queries or reading documentation. I think it's quite clear that if you set up the right similarity approach, then you can start comparing not just code with code, but you can also start comparing database queries with code or documentation content with code. And so subject to the right similarity approach, this then is like the key approach to correlate basically heterogeneous developer actions. Okay, and then the last lesson learned is about how you go systematically about eliminating dark matter. So in a way, it's a little bit like optimizing your program, right? So you should always, by profiling or otherwise, you should always pick the most promising weakness, so to say, of your program in order to put time into improving the performance on that issue, rather than rewriting the program in arbitrary ways. Applied to this context here is we need to keep an eye on all the developer actions that we face, and we need to keep an eye on what of these actions are, kind of, let's say, very frequent, and especially those that are, of course, dark matter events. Those we should pick for kind of trying to make them go white or gray, okay? Yeah, and that's just to wrap up. That's the slide I was showing earlier, just to again connect the topic of developer workflow analysis with MSR. As I was telling you, yes, this is a very much kind of generalized view on MSR insofar that our repositories are very rich. They encompass all the developer actions rather than maybe just the versions in a software repository. And yes, we are not so much interested in generalizable insights like effects or correlations. We are more interested in specific predictions that are directly useful for individual developers or engineers. Okay, thank you.